Hello. Today I was going to go through a homework sheet that I've used in the past just as like an in-class worksheet or a homework handout. I figured we could just sort of go through it together to practice linear regression a little bit more. I think this is going to be our last sort of actual class with new material of the year. The last 2 days of this week, I'm planning to just sort of do some review stuff. Speaking of which, my plan for the final exam is to have something a lot like a final exam, but I want to have it in D2L, and I don't want to bother trying to set up proctoring. So I'm going to set it up on D2L, give you a window of a few days next week where you can do it. And I will set a time limit, 2 or 3 hours, something like that. And you put your answers in D2L and not sort of fill in the blank, retry like our last exam or multiple choice like the quizzes. I think I'll just like leave a blank spot where you can type and then ask you a bunch of questions. And that way you can sort of show some work, and I'll have to grade it by hand, but I can award partial credit. So that's a few words about the final. I'll talk more about it when we have our review days. So this first example here, it says a survey was conducted in the United States and 10 countries from Western Europe to determine the percentage of teenagers who use marijuana and other drugs. Here are the results. So there's 10 different countries, or 11 countries, 10 European countries plus the USA, percent of used marijuana, percent who used other drugs. So basically we want to run a linear regression on this and find out our line formula for the line of best fit, and answer some questions. So I want to know the R-square. I want to know the formula for the line of best fit. There's something here about interpreting the slope, which we haven't really done before, but we'll talk about that. And then we want to use the line to predict the percentage of other drug users if we know the percentage of marijuana users. So I'm just going to highlight the stuff in this table and copy, and then I'm going to flip over to Minitab and paste it over there. So let me share my Minitab screen and get rid of this exam data thing that I was working on earlier. No, I don't want to save it. Okay, so let's paste in these numbers for marijuana and other drugs. Can I type in here? Marijuana and then other drugs. Okay, so let's run our linear regression. So regression, fitted line plot. I want the x coordinate to be marijuana and the y coordinate to be the other drugs. So I guess I'm sort of presuming that marijuana is the one that comes first, and then maybe they move into other drugs, although it's not clear that that's the best presumption. What do we have for graphs? I think I left all this stuff alone before, right? Oh, I did check these boxes to see my confidence and prediction interval, although we never really did anything with those numbers except that they looked cool. So hit OK, and see what we get. So here's our picture. There's a bunch that are low on each, a bunch that are high on each. They kind of go up in a line, like there's not many dots down here. And in the bottom right, there's not many dots down here in the bottom right. There's not many dots here in the top left, although the dots that we do have aren't exactly on the line. Like this one's pretty far, these two are pretty far. So our R squared is okay, but not great. So our R squared number, not the adjusted one, I guess I don't really know how that adjustment works, but this unadjusted one is 78.71%. So I am going to record that over on my Word document, 78.71%. And then we have the formula for our line up here. So other drugs is equal to negative, notice there's a negative there, negative 1.01 plus 0.4947 times the marijuana use. So I'm going to just type that in over on my other document. Other drugs is equal to negative 1.101 plus 0.4947 times the marijuana use number. Okay, so that's basically all the information I want to pull off of this screen. So let's flip back over to the Word document and see what stuff we have to answer. So I pulled in this 71 or 78.71 and my formula here. The slope is the number multiplying the variable, right? In y equals mx plus b, m is multiplying the x, and that is the slope. So interpret the slope in the context of this problem. So basically, if marijuana goes up by 1, then instead of this being like 4 times this number here, the slope, it'll be 5 times the number here, that's the slope. So basically, every time marijuana goes up by 1, the other drugs, the line, is going to go up by 0.4947. So that's the way I think of slope. I think of if you take one step of the right, how much do you go up on the graph? So if marijuana, if you go one step to the right, go up 1 on the marijuana axis, how much do you go up on the other drugs axis? You go up 0.4947. And if there was a negative here, I guess you would go down by the slope, but it's a positive. So my interpretation here is if marijuana use is 1% higher, marijuana goes up by 1, then the other drugs go 0.4947% higher. Okay, higher. When marijuana goes up by 1%, other drugs go up by 0.4947%. At least that's our approximation using our line of best fit. So basically, in this interpretation question, I'm sort of always going to put a 1 in the x-coordinate sort of part of the sentence. The slope goes in this other piece, and the higher and lower depends on whether or not the slope is positive or negative. Here it's positive, so we go up. And the last part here is if a country has 10% of its teenagers use marijuana, let's use the line to predict the percentage of students that use other drugs. So basically, we're just going to plug in 10. Right, those were the units, right? Like this 21 here was 21%. So we want to plug in, this 40 here was 40%. So we want to plug it in as if there was a 10 in this column. So we're going to put a 10 in the marijuana slot in the equation for our line and see what we get. So let me just start an equation here. Okay, I don't know why this is, there must have been a page break after where I typed the equation. So we'll insert our page break again. Okay, so what is our equation? Our other drugs number should be approximately equal to, I guess I'll use an approximate sign, why not? So approximately equal to negative 1.101 plus 0.4947 times 10, because 10 is what we know our marijuana number to be. So I'll quickly pull out my calculator, 0.4947 times 10, and then subtract off 1.101. And I'm getting 3.846. 3.846. That's my guess. So I know that that guess is not likely to be correct, but that's my guess, and it should be an okay guess. This 78% is sort of our measurement of how good our guesses are. You know, basically, like, it's like as compared to just guessing, like if we didn't have any other information, if we didn't know the marijuana number for this mysterious new country and we wanted to guess their other drugs use, the best we could do is just sort of guess the average number. But we can get an improved guess using the additional information of knowing that they had 10% marijuana use. And the measurement of the improvement is, it's kind of like the guess is 78% better. You know, basically how far away you expect to be from the real answer, that error gets reduced by 78%. You know, that's a way of interpreting this R-squared number. Okay, so That's it for the first half. I have another example on the other side of the page here, so we'll do that in a separate video.